Lesson 7 in chapter 1 is going to be about fluently adding and subtracting rational numbers. I haven't really talked about fluently. At this point in the game, you should be doing this pretty second nature. This is supposed to get easier and easier with time because you've experienced it several years over the past couple of years. And you're dealing with mixed numbers. And the key thing about this is, like before, we don't have the same denominators. And so step number 1 up here is to add or subtract the fractions, but you may have to rename them using LCD, or least common denominator, if necessary. Then you're going to add or subtract the whole numbers after you've dealt with the fractions. The last step is add or subtract the whole numbers and then simplify if necessary. So you should be working from right to left, just like you do with whole numbers. You do the same thing with fractions and decimals. You work from right to left. And so I'm going to skip all the examples here, and I'm going to go down to the examples 1, 2, 3, 4, 5, and 6. If you want to read through the examples at the top, that'll give you some more examples just to help you guys out. So in the case of number 1, I've got 1 3/5 plus 4 1/5. I really do want to stress to you that when you are adding mixed numbers, that you go ahead and line these up from top to bottom. And so I'm going to line the problem up from top to bottom. And I want you to notice that I have 1 3/5 and 2 that I'm adding 4 1/5. And so I know that I'm going to add the fractions, and they're both in the same size pieces. Therefore, 3/5 plus 1/5 will give me a total of 4 of my fifths. I don't have to get a common denominator because they have the same denominator, so that's a good thing. And then I add my whole numbers. So 4 plus 1 is 5. So I get 5 4/5. And because 4/5 is consecutive, I can't simplify it at all. I'm going to go to problem number 3 here, and I'm actually going to set up problem 3 off to the side here because I don't have room to put it down here. I'll start running out of room, or actually I could probably put it here. Let's put it there. So I've got 3 2/3 plus 2 1/2. And again, I want you setting these up top to bottom. When we add or subtract decimals, we line them up. In the case of fractions, you can't line up fractions necessarily because they're fractional parts, but you do want to set them up top to bottom so that you do your math correctly. The bottom denominator is a 2 and a 3. 2 and 3 are not divisible by anything in common. Therefore, just multiply 2 times 3, and you'll get the common denominator of 6. So 3 times 2 gave me 6 on the bottom here. So 2 times 2 will give me 4. And on the bottom fraction here, 2 times 3 gave me 6. So 1 times 3 gives me 3. And then I'm going to combine together my 4 6 plus my 3 6 to get a total of 7 6. Now the problem here is that this is an improper fraction. It's bigger on top than it is on the bottom. So I need to take 7 and divide it by 6 to see how many whole times it goes in. And I don't need to worry about the decimal here because I'm not going to be going past that. So we don't want to worry about that decimal there. 6 goes into 7 one time, which is 6, and I get left with 1. And so it's read 1 with a remainder of 1/6 left over. So this improper fraction as a mixed number is 1 1/6. And so I'm not going to be using the improper version. I want to be using the mixed number. So then I switch over to the whole numbers. 3 plus 2 is 5. And I have that additional 1 1/6 because that was what the improper fraction was. So then I combine all those together and I get 6 1/6. So sometimes these problems are going to be kind of involved. And if you notice, this kind of took me a little work to get to that solution. And so you might want to save yourself a work page or some room to do these problems. Question number 5 says 8 take away 6 7/8. And again, I'm going to set this up top to bottom, 8 minus 6 7/8. Now the problem comes into subtraction is that I have 7/8 here, and just like with decimals, or whole numbers, if I have a 0 on top, I can't take something from nothing. So I actually have to borrow from the 8, just like I do with normal numbers borrowing. I borrow a whole. And that's like a whole pie. And that whole pie can be in any size pieces I want to cut it up into. I can cut it into 2 pieces, 3, 4, 5. If I cut it, I want to cut it, because that's what division means, cut it into the same number of pieces as my denominator so that my denominators are the same. So I'm going to cut my whole into 8 pieces. And remember, we're borrowing a whole. That's why we made this a 7. And we're borrowing, that's an 8 right there. Sorry, that's hard to see. We're borrowing 8 pieces. Let's see if I can bring that in a little bit. I'm going to, hold on, that's hard to read. I make this a little easier to read and not get my phone bouncing so much. So that was 7/8. So I want to borrow and make this 8. So how many 8s? I'm going to borrow a whole, and a whole is 8 out of 8 because it's the whole pie. So it's 7 out of 7, or it's 6 out of 6. It's the whole thing. And so I have 8 8s. I take away 7 8s, and I'm left with 1 piece out of 8. So I just subtract my numerators. And then 7 take away 6 is 1. And I get my 1 1/8. Okay, so you have to be careful on that. In this situation, I had to borrow a whole. The whole could be written as any fraction. In this case, I wanted 8s. My size to be 8 pieces. So 8 8s is a whole. And then I was able to do my subtraction. So normal borrowing, you borrow groups of 10. But in fraction world, you borrow whatever the denominator is that you need. Okay, moving over to question number 2. It says I have 2 and 5 6 minus 1 and 1 6. And again, the denominators are the same, so I just subtract 5, take away 1. I get my 4 6. 2 minus 1 is 1. And then I try to see, can I reduce this at all? We always want to make sure we have it in simplest form. Well, both of these numbers are divisible by 2. So I can divide the top by 2. I can divide the bottom by 2. And I get 1 and 2 thirds. And there's my final solution. So this next problem, I'm going to carry it actually over here. So I have a little more room. I've got 5 and 3/4 minus 3 and 1 6. In this situation, I need a common denominator between 4 and 6. Well, 4 doesn't divide into 6. And if I do 4 times 6, I'll get a common denominator, but it's not going to be the smallest one. So I want to teach you guys, and I've talked to you about tic-tac-toe before, putting those denominators 4 and 6 in the tic-tac-toe board and pulling out factors that divide it. Now, normally this would be reducing fractions, but this also works to find a common denominator. So 2 goes into 4 twice, 2 goes into 6 3 times. I don't have anything left that goes into 2 and 3, so I put a 1 and I'm done. And you multiply what you pulled out times what was left in the bottom of the problem. And you multiply, so it'd be 2 times 2 times 3. So 2 times 2 is 4, times 3 is 12. Therefore, 12 is my common denominator. So then you say, okay, how many 4s make 12? That's 3. Whatever I do the bottom, I have to do the top. 6 times 2 gave me 12, so 1 times 2 gives me 2. And then I subtract 9, take away 2 to get my 7/12. And then over here, I'm going to subtract my whole numbers. 5 take away 3 is 2. 7 doesn't divide into 12, and 7's prime. Therefore, I am done with my answer, 2 and 7/12. So that was the answer to number 4. Okay. Moving on to number 6, the last example. 1 and 4/5 plus 3/10. I need to find a common denominator. 5 divides into 10. Therefore, 10 is a nicely shared multiple. I don't need to do anything to this one because 3/10 is just 3/10. It stays the same. But the top fraction I'm going to double so that I can get a common denominator between the two. And then I add my 8/10 plus my 3/10 because it is addition for a total of 11/10. Uh-oh, improper fraction. I'm going to take my 11 and divide it by 10. 10 goes into 11 one time, which is 10. I have a remainder of 1. So this is written 1 and 1/10. So I'm going to put that this is equal to 1 and 1/10. I don't want to use the improper fraction. I want to use the mixed number. And then add over here this 1 whole, because I had 1 whole over here. So I have 1 and, because it's 1, and these parts made 1 and 1/10. So altogether, and I'm just going to go this direction, it's 2 and 1/10. And it's okay to go to the left. Now, equal doesn't mean it has to go to the right. I'm just combining those two answers to get my final solution, 2 and 1/10. So just to recap, you need to make sure that when you're adding or subtracting, they have a common denominator. If you don't have a common denominator, you can tic-tac-toe to find the least common denominator. Now, I could have used 24, 6 times 4 is 24 here, but you would have been dealing with a lot bigger numbers and you would have had to reduce right here. So try to use the least common denominator as much as possible. And so again, you just do your tic-tac-toe board, pull out a common factor, and then multiply what you pulled out times what was left at the bottom, and you'll get your common denominator of 12 by multiplying. And then down here, again, 5 goes into 10, therefore 10 is my common denominator. So you want to look for some shortcuts. Does the one number divide into the other? Am I going to use tic-tac-toe to find the LCD? It's completely up to you. And again, LCD stands for least common denominator, which is why you see the L here, standing for least common denominator, multiplying those out. So this is the conclusion of lesson 7 reteach. And you should be gluing this into your journal at this time. And it should be going on page 17. So I'm going to move right over here to my journal. We're going to have page 17. And this is 1-7. We are learning to fluently add and subtract. Fluently add and subtract. And instead of, it is unlike fractions, but we're mainly dealing with mixed numbers, and sometimes they have the same denominator and sometimes they don't. So just a reminder to fold your paper up so that it is folded with the box right underneath, like so. And then you're going to glue this onto your page 17. All right, look forward to seeing you on the next lesson.